Okay, good morning everyone. I think we have to continue our discussion. What happened is happened, so let's go on. Okay, good morning. Thank you. I'm glad to be here. Today, I, on behalf of my group 1, will be presenting about our work, our research of our work about working plan for remediation of mining facility generating effluent and solid residue containing natural radionuclide. So, as we know that the problem we have here, that is the industry that not properly manage their waste. So it contaminated the land, the soil, the groundwater, and the lake. The waste is also contain some natural radionuclide that bring risk to the population, and the environment must be remediated. This is the flowchart of how the industry works. We have the mining waste, we have the residue and the slag, and the waste is not properly managed. So what can be found about the radionuclide that could be found in the facility? At least it is including the uranium 238 series and thorium 232 series, including radon, radium, lead 210, and so on. So before we go to the remediation plan, we have a complaint about increase of incidence of cancer in the population. So we conclude that it includes a low to moderate dose that statistically observed. So before that, we do some preliminary evaluation on the screening level dose assessment and comparing effective dose with screening criteria. And the conclusion, remediation might be justified. So we can reduce the dose to some reference level between 1 to 20 millisievert per year. After that justification, we do some detailed evaluation, detailed characterization, including safety assessment, conceptual set model, environmental impact assessment, determining contamination level and area of influence. We conduct sampling point in the sludge, in the soil near the public building and waste dump, surface water from the lake, and also the groundwater nearby aquifer. And we found the conclusion that contamination is in water from the lake, groundwater nearby aquifer, waste dumps, sludge from trench, and soil near public building. This is the illustration of the detailed evaluation conceptual set model that we have the source of the waste, the sludge, the liquid effluent here, and it contaminated the lake. The sludge contaminated the groundwater and reaching the human by the consumption of the water, and also there is maybe some contamination into the air. From the detailed evaluation, we made some rank risk of the contamination level. It based on how the contamination interact with the human. The high risk is the direct interaction to human, here from the water. The moderate risk is not really indirect interaction with human, but it interact with the environment or the ecology, and the low is thus not really affected to the human. It's from the gas. It can be dispersed, it can be precipitated, so it doesn't really affect human life. From the detailed evaluation, we also agree that we have to determine the reference level. This is between 1 to 10 millisievert per year. We are also developing measurement parameter, calculating projected dose and comparing projected dose to the active reference level. So the conclusion is remediation is justified. It must be done. The planning is how we reach the optimization of 1 to 10 millisieverts per year. We do evaluation and selecting remedial options through the optimization, developing remediation plan, obtaining regulatory approval for remediation plan. To obtain the decision of what remediation plan should be conducted, we consider the environment, social, and economical dimension. We also conduct a multi-criteria decision analysis for environmental, social, and economic. This is for environmental. We have 5 criteria from the survey, and then we rank the remediation plan. So we have for the emission into the air, we have first rank is containment, and second removal of source, soil and ground condition, removal of source and containment, groundwater, we have immobilization, containment, ecology, we have source removal and containment, and then the last we have source removal and containment. For the social dimension, we have a different rank for the technology. For human health and safety, we have first containment, immobilization, and the third is source removal and separation, same. Ethic and equity, all will be 1 ranking. Neighborhood and locality, 1 containment, immobilization, and source removal or separation. Communities and community involvement, all to be 1, and uncertainty and evidence, all to be 1. And the last is the economic dimension. We have the category, the criteria is the economic cost. We have rank immobilization first, containment second, the third is removal of source. Indirect economic costs, we rank containment. Employment, we rank all 1. Induced economic and benefit, all 1. And the last project left. And flexibility, we rank removal of source, containment, and immobilization. After the ranking, we do the multi-criteria decision analysis, and we conclude that the best option is containment because it shows the high strength, and the remediation plan could be included containment for liquid effluent so that it will not contaminate the lake, and also installing subsurface barriers below the pit to stop infiltration to the groundwater. After that, after the planning, and then we determine the end state for the site. We do several consideration: adaptive remediation determination process, zoning operable management unit, use of long-term stewardship, waste management constraint, stakeholder opinion, decommissioning consent, environmental consent, and also funding constraint. So that the end state will be like this. For the economic dimension, we will build a photovoltaic power plant in the industrial site. For the lake, for environmental, we preserve the lake so that the ecology is there, not being disturbed. And for social, we can do some training for photovoltaic recycler and workplaces for former mine workers. We also conduct several stakeholder engagement. The stakeholder including project owner, employee, local government, people who live and work near facility, interested, non-governmental, and other organizations of civil society. We do several engagement here, right here. Also funding organization, business, and state authorities. And then the final of what we do, the completion of decommissioning, we conduct final survey, demonstration of compliance with end state criteria, end state in context of multi-facility site, partial site release, regulatory process and decision, definition of institutional control in case of release restriction, introduce new practice on site, graded approach, justification, optimization, and also involvement of interested parties. After the remedial action, we still do post-remedial management, like performing remedial action, comparing effective dose to residual dose, and confirm that end state criteria are met. And still, post-remedial management is conducted. We have to decide if ongoing control is needed. thank you. I think this is the last of our work. Thank you for the attention.
So, my take is that, well, of course, there are comments to your presentation, but I guess that if we dig in the comments, that will affect the others. So my suggestion is that we have all the presentations, we take our notes, and then we can make comments that are specific to the presentation and more generic in nature. I hope that you agree with me. Just to mention, it's important you did introduce your group. So it's Andrea, yes, yourself, Fenian, good, and Vasily. So this is the group. You are also in the group?
Yeah. Nice.
Oh, all right, because I apologize because I didn't put it here. Okay, so let's move to group 2. Thank you.
Hello, good morning. I don't know if I can open the Socrates. Also, we try to do some things there, but it's fast. It's okay. Yeah, I saved and I just on the website. Okay, I'll put it. Thank you. Because it's part of our presentation, so thank you. Well, we are the group 2, Thiago, Adi, Ahmad, Yana, and Anna. Well, this is an overview. So we treat this project doing step by step of these 9 steps. So we start with the identification of source sector, the conceptual model sites, estimate those received, the environmental assessment, consider scenarios, adding value informed contamination land, stakeholders involvement, indicators for environmental, social, and economic, multi-criteria analysis, Socrates, I will show what we could do, implementation and conclusions. So the first step was the identification of source term. I'll pass what is our issue because the group 1 already did. So we identify the uranium-238 and thorium-232. Also the daughters radon-222 and 220. And we put here the half time, so they are elements with a long long years to half time, and radon it's so short, the half time, seconds. And we had a lot of discussion about if this issue was a planned exposure or existing exposure. So we have discussed this in our groups and in your group, and we didn't for sure know, because we need more information maybe to define that. So we put the both criteria here, so the dose limits for a planned exposure situation to 1 millisievert to achieve after the remediation, and for existing exposure, something between 1 and 20, that it's a reference level. So this is our conceptual model of sites, and we are trying to think all the pathways, all the sources, and this picture we use and put our views about that. So you can see here the waste located in trenches, and this can be impacting the groundwater, the soil, the uptake by plants, and also the discharge of effluent going to the lake, and this can access the fish, all the other animals. We also put here a well for consumption of water of some near population. So atmospheric also we consider, but radon, like we saw during this week, maybe in this situation it's not so relevant, because they are buried in the soil, so the dispersion of this to the population is irrelevant. But we put this because maybe it's an important question during the process. Sometime we will ask, what about the radon? So you can treat this. And maybe it's more relevant for the workers, because they are on top of the waste and closest. So this is our conceptual model. And after that, we need to think about how to estimate this dose. So we have here all the pathways. So you can see here like sedimentation, bioaccumulation, drinking, ingestion, irrigation, and this is for water, and from there, inhalation, the plume immersion. So we have all these pathways. In the total, it's what important to us. So it's important to define that those we are achieving since the beginning, because this is after all our evaluation, we get one total of those. And consider scenarios. We will put 2 scenarios: remediation and continue the operation. And remediation are 4 types, 4 technologies I will show after. And the ER project, looking for termination of the company. It's one of the proposal from the community, and creation and recreation area. So to end state, we could use modernization of the enterprise and technology process, creating a controlled area to prevent population exposure, new jobs for the local community by involving in remediation work. So this is the end state, that we do the remediation but still operate. And the second is the termination. So removing all the radioactive waste and associated pollution, change the infrastructure of the city due to the removal of the enterprise. So these are the 4 techniques: the removal of source, the containment, the immobilization, separation, and all this. It's better for one pathway and to another, so I will don't dig that. And this is our 6th step: identify the stakeholders' involvement. This mind map was made for ABI. It illustrates very well all the stakeholders involved. So regulatory body, and they have some tasks, some responsibilities, like develop and enforce regulations, review and approve the commission, create guidelines,
So the public, the community, financial institution, well, employees, all are in this. It's important to bring to us to participate since the beginning. And after that, we have the indicators for environmental, social, and economic categories. So 5 indicators for each categories. And this is the result we did together. Yeah. So for environmental, the ranking, the top one is containment, because they have a potential for significant reduction of contributions from soil and groundwater pathways. On the other hand, it requires a large amount of materials for civil engineering workings, potential for use and reuse materials, linking that with the concept of circularity. And the last one is removal. So I would say just the best and the worst in this case. So containment and immobilization are in the top 1 and 2. Removal, the last. Economic immobilization, again, because the cost is low, and it's lowest than the others, and removal is the cheap. It's more expensive. So the immobilization the cheapest one. So we had these to economic and social. All have good points, positive aspects in social, but containment we consider has more value in this aspect, because in terms of human health and safety, there is less exposure to the material for workers in the community, potential for significant reduction of contributions for soil and groundwater. So we think about that in this case. And now we go to Socrates. So we did this just to look thinking about these technologies, and in the Socrates we try to use just to illustrate, but we put these four alternatives. Yes. So 3, it's looking for the operation after remediation, continue operating, but using removal of source, the containment, and the immobilization. And one last alternative we put is the remediation, but after that the termination of the enterprise. So we create these 4 alternatives. We create these dimensions: economic, environmental, social, and technical. And we put some objectives like economic, direct economic costs and benefits. We put like criteria, the remediation costs, operational costs, and job creation. So we did this to some of these. One important is the technical, if it's feasible or not, for what is the impression of the stakeholders about that. And human health and safety, so the exposure to material, like I said, if you wanna go to put it to another place, you have the transportation and the excavation, and this is exposure to higher doses. So we put this and did the matrix of the impacts. And well, I'll go to the results. Okay, so in the ranking we got immobilization, like and continue operating as the solution for the solution. Not the best, but the compromise solution. And in second, containment. In third, remediation termination. And after that, we try to use the equity analysis. So we put 3 groups, and the last group is the group remediation, and after that, termination. And you put more weight here, just to see if the population, or if one group wants to do something, what happens with this analysis. So we put 3 groups. The first one is adapt. It's not like that, but just to see what happens. It's adapt to removal and operation. The second one, not removal, so containment and immobilization, but continue operating. And the third one, remediation termination. So after that, we put like the last group is remediation termination. So the best option is remediation termination. Very good. And the worst maybe is immobilization. We did that, and after that we have these results. Let me check. Immobilization. Where can I see the? Equity, yeah, equity. So the first was removal of source operation, and the second remediation termination. That happened. Termination was third, and after that it already is the second. So we conclude this. Well, in initial evaluation, containment by the technical person for the enterprise was considered the best technical option. With the multi-criteria analysis, the immobilization technology came out on top, but containment was still considered a good solution, was the second. And considered the different weights for different social actors, the most suitable solution did not change. It's the same, the immobilization, but the termination option gained in strength. So that's it. We try to analyze just a little about that. What is changed? Né? If you have maybe for the technical people, one solution is so clear, but to the majority of other social groups, other option it's better. This need to be. We have to compromise. Né? We have to get a compromise solution. So that's it. Thank you.
Group 3.
Okay, so good morning again. We are presenting group number 3. It's Anastasia, Nazali, Mohammed, Mustafa, and myself, Mujde. Three of us will try to present together. So we've done a description of the problem, which resulted in some assumptions. We made some assumptions. Then we did the conceptual site model, sustainability assessment, using the SURF UK model, and conclusions and recommendations. We hopefully will do multi-criteria analysis assessment later on after this course using the Socrates. So with the description of the exercise, within the description we did some highlights which helped us to identify or define important elements like containments of concern. You can see the highlights, definition of release mechanisms, exposure routes and receptors, so far and so forth. And then we came to this assumption of problems, which I'll ask Mohammed to present.
Thank you. During our brainstorming session, we have discussed some of the assumptions to be included for our case study. The first one regarding the industrial operations were not subjected for any regulations when it firstly gone for operations. There is no evidence that the factory is considered as a licensee at all. When there are a lot of significant impact on the local population, health like cancer occur, they start to push to reform some regulatory pressure to do such regulations. The long-term economic and social importance of the company to the local community may create some political pressure on the regulator to do such regulation, and termination of the operation, discharging of some of contaminant of concern like liquid effluents and so on, nearly to the lake, may lead to contamination of the lake and groundwater and the aquifer as well, which is used for drinking water. The improper disposal have caused the soil and the ground contamination over time. This is But the last assumption will be we need to have a compromise solution considering the environmental and social and economical aspect. It's very challenging case. So we will proceed to the next one. Regarding the stakeholders, just preliminary concerns from my plant. I have a practice for stakeholder. I can just demonstrate it from a very high level. Okay. Regarding stakeholders, you have to identify your stakeholders first, as we done here. Then analyze your stakeholders. Those analysis would be based on the possession of stakeholder, if it is supported, proposal, and so on. Could be their needs, for example, expectations, their strength, weaknesses. Those aspects will be considered as later on as a basis for weighting those stakeholders, and then finally mapping our stakeholders based on our interest matrix. In the power interest matrix, we have here power or influence, and we have here the interest. And according to the parameters which we use for power and interest, as you know, stakeholder management process, it's a little bit subjective sometimes, so we need to make it objective. So you can set here some of parameters with a weighting factor to evaluate which stakeholder is important than the other, and then according to the possession of the stakeholders in the power interest matrix, you will have the proper engagement strategy and involvement. Okay, and then manage the complaints of the stakeholder to keep them informed about your decision. For example, one of stakeholder will be the local communities. The main concern is the exposure of the radiation and so on. The company management, the government authorities, workers and unions, legal experts, and so on. So the next one, the conceptual site model, we will discuss.
So we did the conceptual site model in tabular and also an illustrative options. So we have two main sections: liquid effluents, where the contaminant of concerns are thorium and uranium, and we also have non-radiological contaminants such as process material, sulfuric acid, and other byproducts like PBZN. Release mechanisms are identified as leaching, release, leakage. Then we have the environmental mediums like surface water, groundwater, and soil through which these contaminants might reach our receptors. And for this group of contaminants, the exposure routes they come from soil to surf water or groundwater, and then through ingestion to the receptors, which can be flora and fauna, humankind, river nutrient chain, including the fishes, microorganisms, and algae. Then we have these solid residues, sludges, like silicon dioxide, again thorium and uranium, and sediments, which is a result of flooded tailings, heavy rainfall, which go around, and those sediments are, let's say, accumulated on soil and rock, and through soil and rock and air, they might go and enter the root of the flora and fauna, and from there they can reach humankind and animals. And here is a graphical illustration of the conceptual site model. We have different receptors: the kid swimming, the guy walking the dog, people in the recreational area in the restaurant are eating maybe some of the veggies growing around, or the fruit, or drinking the water received from the aquifer. So these are the, let's say, routes through which the contamination can reach people or our receptors. Mustafa, do you want to add anything about the uranium and thorium in English or Farsi? Please. Sorry. May I? Oh, please. Yeah. Okay. So we assume that the mining process is based on heap leaching. There are these there are the accumulated mining ores, and we have the accumulation of the waste. So the contamination, source of contaminations, the chain of decay is one of the key sources of contamination. So we know that in most of the mineral ores, silicon is available. So PM 2.5 and PM 10 consider these releases of such, let's say, minerals as a result of the decay process. Okay. So these are the what we've assumed and we considered in this process. This is a AI-based generated illustration of the situation we had. So just for fun, we included, and then we used we did this sustainability assessment. We have these three areas: environmental, social, and economic, and then we use these SURF UK criteria to evaluate each. Based on this evaluation, containment is considered one of the, let's say, best options here, followed by immobilization as the second best rank, then removal of source, and finally separation. And we also assessed the impact of decommissioning from those three aspects. For example, in terms of environment, if we, let's say, terminate the operations of the organization and we do the decommissioning, we find that from some point forward, the company might no longer realize its responsibilities due to various reasons, for example, bankruptcy or inefficient monitoring of environmental aspects and efficiency of remediation measures which have diverse impact. From social point of view, increased rate of unemployment and impact on human health and safety due to inefficient monitoring of remediation measures. And from economic wise, as the corporation has a direct participation, it's financing some of the, let's say, local operations. Reduced financial inputs for the community is an impact, and additional expenses to maintain the environment and human health and safety will be, let's say, the adverse results of decommissioning the facility. And here are some of our conclusions. We found that maintaining the activities of the organization that's our recommendation, and in that case we require the organization to first develop and implement a comprehensive integrated management system, including an environmental management plan. And we then added some boxes to highlight what are the aspects included, like social, environmental, economic, and the three dots means quality, etc., etc. Then develop an initial decommissioning plan, which is must. Engage and involve stakeholders to ensure communication and consultation. Consider containment as a remediation technology and assess the feasibility of exploiting the byproducts, which will ensure some financial assets which can be then injected into a revolving fund, which will be later on allocated to environmental remediation and final decommissioning after the completion of the operation. And then implement preliminary evaluation and detailed evaluation of remediation process, justification of it, which is a must. Plan the remediation, consider optimization so that we will protect and safeguard all aspects. during the, let's say, implementation, and finally post-remediation management, that these are things that we need to take into consideration. And this is all. Thank you.